All right, it's time to jump in and take a look at some problems that have radicals in them, and we need to simplify. And I tried to pick a couple of problems that most people would look at and go, oh, this is just too hard. I don't even want to try. Especially as you look at the first one to the left there. It has a fraction in it. Most people go, uh-oh, fraction, can't do it. So I want to give you a couple of strategies to use. And honestly, you have all these strategies already. Sometimes you just don't realize that it would be beneficial to write things a certain way. So the first thing I'm going to recognize in this problem is, yes, I do have a fraction. You know what that means? That means I'm going to try to write everything as a fraction because stuff just fits together better when they're all kind of the same. So I'm going to begin this problem by writing this part right here as a fraction. Well, you can write a whole bunch of fractions that happen to equal 4. But I'm going to write the easiest one, 4 over 1. And notice how there's nothing between the 4 and the radical. So that means if they're written right next to each other, it must be multiplication. And now I'm going to write the second piece as a fraction also. You say, well, it already is a fraction. Yeah, but I'm going to change things up a little bit. I'm not going to change what it means, but I'm just going to change the way it looks. I'm going to split it into two separate radicals. And as long as it's multiplication or division, it's okay to do that. I can put them together when it suits me. I can split them apart when it suits me. You have to be creative enough to say, what would make this better for me to work with? Okay, sometimes that's not in the instructions. It's not told you in any directions. You just have to be creative enough to look at it and say, how can I make this look a different way without changing its meaning and make it more conducive to whatever I need to do, to however I need to understand it? Now, some of you look at this and say, well, it doesn't make it any better. But for me, it does, because if I notice that I'm multiplying fractions, that means I can just multiply straight across. Okay, I don't need any common denominator when I multiply fractions. I just multiply straight across. So I get this 4 times the square root of 5 on top. And on the bottom, I get 1, which I don't need to write, times the square root of 36. And that just happens to be one of those perfect squares that we need to recognize. Okay, when those show up in a problem, they're not there on accident. They're there for a reason. And if you can immediately recognize them, you can get so quick at these, you don't even think about it when you do it. Square root of 36 is 6. Okay, now what I'm going to do is I'm going to remind you that this problem right here looks kind of like this. Okay, now all I did was replace the square root of 5 with an x. And the reason I did that is, do you know what x is? No, it's a variable. It could be anything. So we don't do much with it, but we know that the 4 and the 6 are both whole numbers, and we can simplify those. We can reduce them. Now, when you look over here, do you know what square root of 5 is? No, not really. Okay, you could punch in a calculator and get the answer and get a decimal that never ends, but it's not something you'd know off the top of your head. But it doesn't really matter. We're not going to change that. We're just going to look at this right here and say, hey, I got 4 divided by 6. Yeah, it's multiplied by some number, but don't worry about that. 4 divided by 6. Well, if I take those and cut them both in half, I'm going to get 2/3. So this whole thing can reduce to 2/3, and then you have a square root 5 on top. And that is the simplified version of that mess we started with in red. Now, let's take a look over here at the second one. This one's multiplication instead of division, but we can still use our same principles here. We have all this junk multiplied together. Now, a lot of people have a tendency to want to go, oh, let's do 3 times 6. We can't do that, though, because that isn't really 6. I know it looks like it, but that's really not a 6 there. That is the square root of 6. And the square root of 6 is some decimal you don't know, so it's kind of disguised. It's not really a 6. So let's take the numbers that we don't know. They both happen to be radicals. Okay, so this is a radical, and this is a radical, and one of the things we've learned is that it's okay to multiply those together as long as they're both square roots. So I'm going to write this as 3 times the square root of 48. And now what I'm going to do is I'm going to look to see if there's a perfect square that goes into 48. Well, there's actually a couple of them. I could do 24 times 1. Nope, 1's a perfect square. Or I'm sorry, 24 times 2. Okay. 48 times 1, that doesn't really help us. Let's see, how about 4 times 12, 16 times 3. Now notice 4 is a perfect square, but so is 16. And what we've learned so far is let's use the biggest perfect square to make our work just a little bit easier. So I'm going to break this down into the square root of 16 times the square root of 3. And notice, don't forget this, I still have that 3 out there. All this stuff is multiplied together. Now what's nice about this is that happens to be a perfect square that we can interpret. That's 4. I have 3 times 4 times the square root of 3. Remember, the square root of 3 is some decimal that goes on forever. I don't know it. I don't really care. I'm just going to leave it there rather than try to change it. So in this case, I get 3 times 4. Those are whole numbers that I can deal with. That's 12, all multiplied by the square root of 3. And see, the goal here was to take all this junk here and try and get the smallest number possible that's still under the square root sign without changing what it means. That way we've taken out all the whole numbers that we can interpret. We've only left the little tiny bit, the remainder basically, that's there that we can't interpret, that we're not really sure about. It's not a number that's easy to remember. And that would be the simplified version of this. So hopefully that gives you a little bit of strategy. When you see something that looks complicated, whether it's a fraction or a multiplication problem, remember, you have the skills to do this. It takes some practice, like I said before. It doesn't happen right away. But you have the skills to jump in and try to write things a different way and be creative with it. And eventually you get used to what works most of the time and what you kind of want to avoid that makes it worse. So good luck in your work there. This is one of those things, like I said, that is pretty tough for students to pick up the first time around. It just takes some practice. So don't get frustrated. Just keep working at it.